January 18th. Okay, that's just a quick run through of what we did yesterday. Okay. One thing we didn't talk, so we talked about how to go from degree, minute, seconds to just regular degrees, regular old degrees. Yeah, Maddie? Okay. Oh, yeah, I saw. I remember. All right. All right. We talked about going from degrees, minutes, seconds to decimal, right? You just do the degrees plus however many minutes over 60 plus however many seconds over 3,600. Okay. That's how to go from degrees, minutes, seconds to decimal degrees. We talked about how to go between decimal degrees and radians. Does anyone know what I mean by decimal degrees? Just like regular old like decimal 173.1745. Okay. We talked about how to go from between here and here. We talked about how to go from here to here. We did not talk about how to go from decimal degrees to degree, minute, second degrees. So let's do that right now. So I'm looking at heading 2 on these 4.1 notes. Convert from decimal form to degrees, minutes, seconds. Okay. So 103.74. That's what that number is. It's a little hard to read. Okay. Okay. Here's how we convert. Okay. So we have 103.74 degrees. So the degree reading is going to be 103 degrees. Okay. And all we do to figure out how many minutes are in 0.74 degrees is we multiply 0.74 by 60. Okay, that little apostrophe mark, that means minutes. That's just a symbol that means minutes. Okay. So let's use our calculators. Let's see how many minutes are in 0.74 degrees. 0.74 times 60 is 44.4. So we're going to have 44.4 minutes. Okay. Anyone have any guess as to how we get the seconds out of that number? How we go from, we have degrees, now we have minutes. How do I get the seconds? Exactly, yep. So all we do, we take that 0.4 then. So we just take this 0.4, okay, and we multiply it by 60. That's going to give us the number of seconds, okay? So you just multiply like the decimal part by 60 twice. The first time you do it, that gives you, yes?
If there's no like decimal minutes, there's no seconds.
Just like 0 seconds, yeah. Yeah, so the first multiply by 60 gives you your number of minutes. The second one gives you your number of seconds. So 0.4 times 60 is 24, okay? So 44 minutes. 24 seconds. The double, like the quotation, the double apostrophe thing is a symbol that means seconds. So 103 degrees, this is our answer right here. How are we feeling about this? Okay, so 103 degrees, 44 minutes, 24 seconds. Can we do B on our own then? Let's try B on our own.
Wait,
Yeah.
I'm confused on like what the 1 and the 11.
The 1 and the 11? Oh, like this little symbol?
Yeah.
This is just a little like quotation. This is just an apostrophe. It's just a symbol that means minutes. Like degrees, you know how like the circle, it's just like that, but it means minutes. And then this is just like that, but it means seconds. Does that make sense?
Yeah.
So try to do B on your own. Okay, did anyone leave their white TI-84 in here over break? That's not from this class? Okay. We're charged for 2 weeks. Charging for 2 weeks, so the battery should be full. Actually, like 3 weeks. Okay, try to do B on your own. Give you a couple seconds. I'll do it on my own as well. All right, what do we get? Anyone got the answer? Anyone have the answer? Yes.
18 degrees, 46 minutes, 12 seconds.
Yep, good job.
So is the last decimal point, or like the last 100, because I'm multiple is 0.77 times 6, and does it times 6?
Times 60. You should get 46.2. When you do that, you keep...
I got 4.60.
Okay, about the wrong number, okay. All right, so that's my answer. Good job.
that plus? Like, it's not plus, it's just those listed in like.
Yeah, technically it's plus, but yeah, you list them in sequential order as well. Yeah. Sorry about the confusion on the last one. Yeah. Okay. So are we feeling okay about that? All right. Let's go on to number 4. So convert to radians with your calculator. So now they're giving us degrees, minutes, seconds, and we want our answer in radians. So I drew this little flow chart up here because you have to go from, well, this is the way I would do it at least. You have to go from degrees, minutes, seconds to decimal degrees, then to radians. If that makes any sense. Okay. So let's go from degrees, minutes, seconds to decimal degrees. Okay. So we have 73 degrees and 12 minutes. How do I convert that to just regular like decimal degrees? 73 degrees. So it's going to be 73 plus 12 over 60 degrees. Okay. Use your calculator. And it's going to give you 73.2 degrees. Okay, so we went from degrees, minutes, seconds to decimal degrees. Right now, second step, we got to go from decimal degrees to radians. How do I go from degrees to radians again? Yeah, just multiply by pi over 180. Yep, good job. That gives us, I got 1.28 radians, rads. All right. We feel okay about that? All right, when you're ready, go ahead and try B on your own then. And I'll try it on my own. All right, whenever you have it, raise your hand. Use the pi button on your calculator. Do you know where the pi button is? Where do you use it? It should be right there. So you got to do second.
Oh,
Yeah, I got 30 some answers. So you should do pi. I think it doesn't matter. Oh, it's got 50, that's got to be 51 over 36. Big 180 over pi, should be pi 180. Yeah. All right, guys, I'll do this one real quick for you guys. Okay, so part B, we start from that DMS number they gave us. We want to convert it to decimal, right? Okay. So 190, we convert that with, we do 190 plus 18 over 60 plus 51 over 3600, right? My minutes over 60, my seconds over 3600. Okay, that's going to equal about 190.31 degrees, okay? And then we just multiply that number, 190.31 degrees, we multiply it by pi over 180. Okay. And I got 3.32. Is that what you guys got? Okay, cool.
You got what?
3.32. Okay, we feeling okay about that one? All right, kind of jumping around on here. Radians to degrees, convert these to 3 radians. So I give you 3 radians. Oh, whoops. 3 rad and 1.6 rad. Convert those to degrees real quick for me. So yeah, does anyone remember how to convert degrees to radians? Or radians to degrees?
You just divide.
Times 180 over pi. You can divide by pi over 180 too. It's the same
And
thing.
then what do you do after that?
Multiply by 180 over pi. So to go from degrees to radians, you do multiply by pi over 180. To go the opposite way, to go radians to degrees, you multiply by 180 over pi.
What do we?
I think the notes might be.
Oh, really? Okay.
I mean, they could, because it says from radians to degrees, it's,
Yeah, from radians to degrees, you multiply by 180 over pi. Did I misspeak?
I don't know.
So that's all we have to
So
do.
what are we doing now?
Convert these two numbers to degrees. Yeah.
To the decimal. Decimal.
Decimal degrees, yeah.
I know what I'm doing.
So 3 radians, how do you convert that to degrees? Multiply by 180 over pi.
Yeah, for radians to degree, right?
Yeah.
Okay, so then for degrees to radians, you divide up. So we just multiply by like 5.
Either of those, yeah. I guess. Yeah. You want to put your phone away? You can use this calculator. So we're converting C and D to radians. Anyone have C? Anyone get C? Yes.
Is it 171.9 degrees?
Yeah, good job. Yep, 100. What's that? Yeah. So to go to convert from, so this is to convert from radians to degrees. You just take the number they give you, multiply by 180 over pi. We went over this yesterday, so that's why. And then to go the opposite way, to go from degrees to radians, you multiply by pi over 180. So if you do 3 times 180 over pi, you should get 171.9. Precisely. And then what do we get for D? Anyone get D? Good. Yep, 91.67. Good stuff. Awesome. Good stuff. All right, so just different. All this first page was all sorts of different ways of converting between the different units we can use to measure angles. Any other questions?
Do we have to do anything like with the circles?
Yeah, we will. Yeah, we do. Oh, yeah, we do. What's that? Yeah, we do a lot of radians. Never goes away, ever. Yeah, that's all good. You get used to it. It becomes a second language. So, all right, number 6A. Anyone have any idea for this one? A 100-degree arc of a circle has a length of 7 centimeters. What is the radius of the circle? Yeah, okay, yes. Does anyone remember the formula that gives you arc length? Anyone remember the arc length formula? Arc length. Yep. Okay. Arc length S. We're using S to denote arc length. That equals R theta. But Maddie's point, where theta is in radians. Theta has to be in radians. Okay. So the first step here is to convert 100 degrees to radians. How do I convert degrees to radians? multiplied by pi over 180, yeah. So doing that, we get 100 degrees times pi over 180. What's that, 5 pi over 9? 5 pi over 9 radians.
Is that the answer?
That's the angle. We had to convert. We're going to get the answer using our formula, S equals r theta.
What's theta?
Theta is, yeah, I'm sorry. Theta is the measure of, so we're talking about a 100-degree arc of a circle. What that means is theta is, it's not a good marker. Theta is the measure of the central angle of that arc. So basically what's going on is we have a circle. I have like a pizza. And I have a central angle here that's 100 degrees. And the length of like this piece of the crust is 7 centimeters. So theta is the central angle right there.
So 100?
It's 100 degrees, yep.
Okay.
Yep. But we had to convert it to radians to use the arc length formula. And they want to know what the radius is. Okay, so we converted our central angle to radians. So it's 5 pi, 100 degrees is 5 pi over 9 radians, okay? Now we can use the formula. So we have S equals r theta, okay? What did they give us for S? 7. And then theta is what? 5 pi over 9. Okay? And then we just need to solve for r. Okay? So just solve this equation for r. Yep.
So S is just the length of like
That,
the crust?
yeah, that slice of crust.
Okay.
Yeah. So r is so 9 over 5 pi times 7. So using my calculator, I got the radius is 4.01 centimeters. Is that what you guys had? Okay, so this problem was just using the arc length formula, and I needed to make sure that my angle, that central angle they gave me, was in radians first. Okay? Yeah.
Can you go over how you solve for R?
For r, yeah. So I plugged in 7 for the arc length. I plugged in 5 pi over 9 for the angle. So now I have 7 equals r times 5 pi over 9, right? When we're solving for a variable that's multiplied by a number, right, we divide by that number. Dividing by 5 pi over 9 is the same as multiplying by 9 over 5 pi. Yeah, so I did that kind of fast. Are we feeling okay? Multiplied 7 by 9 over 5 pi. You said you got 39? 7 times 9 over 5 pi, that's exactly what I did, right? That's so good. It's something to do, you did it right, it's something to do with the calculator. Okay, here's what's going on. That 5 pi is being parentheses. So what your calculator is doing, it's doing 9/5 times pi, and it's doing 9 over 5 pi. Yeah, pi's in the numerator for you. Yeah. All right, are we okay if I move on? Can I talk about B? Okay. What's the perimeter of a 10-degree sector cut from a circular disc with radius 11 inches? Okay. So let me draw a circle. Here's a circle. Okay. So we've got a circle. All right, so I'm cutting out a little slice of that circle, a little slice of pizza. All right, and a 10-degree sector, what that means is the angle at the center of the piece of pizza is 10 degrees, okay? So they want to know the perimeter of that little slice, this little 10-degree slice, okay? So that perimeter is going to be made up of what? So there's going to be, let's see if I can, the perimeter is going to be this radius right here, plus this side of the piece of pizza, those are both just the radius, plus that arc length, the length of the crust, okay? The length of the two sides of the piece of pizza plus the length of the crust, right? Right? So the length of the crust, that's the arc length, right? So to get that, we use S equals R theta, use that formula, okay? And then the radii, does it give you the radius? Yeah. The radii, it just gives you, it's 11 inches, okay? So our piece of pizza, we got the radii. So we have these two side lengths. They're both 11, okay? I just got that from reading the problem, 11 inches, I should say. And then what do I have to do before I can use the arc length formula? Yep, I have to convert that 10 degrees to radians. So 10 degrees times pi over 180, that's pi over 18, right? Equals pi over 18 radians, okay? So S is going to be 11 times pi over 18. Oh, shoot. Which is about 1.92 inches. Okay. So the two sides are 11 inches. That's just the radius of the circle. And then the little crust length is 1.92 inches. Adding those all up, we get the perimeter. 11 plus 11 plus 1.92. So totaling it all up, we get 11 plus 11 plus 1.92, which is 23.92 inches. We follow that? So we just had to add up the two radii plus the crust, the arc length. Feeling okay? Okay. All right, can I move on to the C, the concentric circles? The concentric circles of an archery target are 6 inches apart. So here's what's going on here. There's like a big red circle. All right, anyone do the archery J term? No, okay. There's a big red circle, okay, and then there's like a smaller blue circle. I'll draw a smaller blue circle. And they're concentric. That means they have the same circle. My art skills are terrible. I apologize. Okay, and then the center. So there's a small blue circle, a big red circle. They have the same center. They have the same center, okay? They're 6 inches apart. Okay, they're 6 inches apart. So what that means, I'm going to draw a dotted line here. The outside, the crust of the blue circle, is 6 inches from the crust of the red circle. Okay? All right. In the inner circle, that blue circle has a circumference. So I'm going to do blue circumference equals 37.7 inches. Okay? And we want the red circumference. Okay? Okay. What's the formula in general for circumference? You guys remember from geometry? That's area.
2 pi r.
2 pi r, yep. 2 pi r is circumference, right? We don't know r, though. We don't know the red radius, do we? We don't actually know that. So how do you think we might get that? Well, we do. So do you guys see how the red radius, the radius of the red circle, is just 6 inches more than the radius of the blue circle? Yeah.
We're trying to find the radius of the blue circle.
Yeah.
6 to that.
Yep, exactly. We want to find the radius of the blue circle. Yep. How do I do that? So the circumference of the blue circle is also 2 pi r, right? And we know that equals 37.7. So right here, do you guys see an equation I can solve for r?
37.7.
Yep, so r is equal to 37.7 over 2 pi. Okay. So then the red radius is just going to be 37.7 over 2 pi plus 6. Just got to add 6 to that. Now we can get the circumference. It's going to be c equals 2 pi times the red radius, which is 37.7 over 2 pi plus 6. Just slap that in your calculator. Right there. All right. I feel like I went through that kind of fast. Did you guys at least follow? No? Okay, that's okay. So we want the circumference of the red circle. It's going to be 2 pi times the radius of the red circle. Okay? So to use this circumference formula, we need the radius of the red circle. We know that it's going to be 6 inches more than the smaller blue radius. Okay?
Why don't you do 12?
Yeah, why don't we just add 6 to the first radius?
Oh, it should be 12. You're right. Wait, no. Should it?
Yeah.
You'd add 12 to the diameter. What do you mean? Why don't we just add 12 to the first radius?
So 12 is the radius, and we add 12 to 37.7.
We don't know the radius of the.
So then how do we know all that for the round?
And raise the inner circle.
No, the radius of the inner circle is not 6. That's just the distance between the two circles.
37. So it is 2 pi.
Let me draw in the radius. That's the radius of the small circle.
Okay, so it's 6 pi.
Yeah.
So this is 37.7.
The radius of the No. Oh, is it? Oh, that's a coincidence. It's very close to 6.
Well,
Oh,
Yeah, it's very close to 6. It's not quite 6.
oh, okay.
the other one.
So you get that, then you add 6, and it's 12. Okay. Would you guys prefer like I crunch more numbers along the way? Okay. Yeah. All right, guys. Let me run through this again. I can crunch more numbers along the way. So, did you guys follow that the radius of the blue circle is 37.7 over 2 pi? Okay. That's about, what'd you say it was, Ben?
Like 6.
That's about 6, okay? So then the radius of the red circle we get by taking the radius of the blue circle and adding 6. That gives me 12, okay? So I'm used to just not doing all the calculations till the end. Okay? So now that we have the radius of the red circle, which is 12, we can just pop that into this circumference formula. C equals 2 pi times 12, which is 24 pi, which we can give a decimal answer if we want. 75.4. And that's in inches. All right. Okay, so we wanted the perimeter of the red circle, the circumference. We needed so to get that, we needed the radius of the red circle. To get the radius of the red circle, we needed the radius of the blue circle.
How do we know the radius is 6
The radius of the blue circle, we know that 2 pi r for the blue circle equals 37.7. That's given in the problem. Solving that for r, 37.7 over 2 pi, that gives us about 6. So the small radius, the small circle radius is 6. Okay? So we use the circumference formula in 2 different ways in this problem. And then to go from the small radius to the big radius, we added a 6 on top of that, because they're 6 inches apart. So the radius of the big circle is 12. So their 2 pi r for the big circle is just 2 pi times 12, 24 pi. We feeling okay about that? No? It's okay. That's 24 pi in your calculator. You put it in your calculator. Yeah. $75.4, yeah. Yes. All right, I got to move on to part D, okay? Find the angle in degrees that describes the compass bearing, northeast, okay? So we got a compass, okay? Going from north to northeast. That's what like fraction of the circle? 1/8, yep. So to find that angle in degrees, you just do 360 divided by 8. 1/8 of 360. $360, yeah, what's up? I see your calculator. You have to put 2 pi for it. Yeah. Have you guys ever used a compass before? Okay. It's all good. Yeah. You gotta, when you're in the woods, you gotta get around somehow. My parents didn't let me have a phone until I was like in high school, so. So the way a compass works is north, like there's 360 degrees in a circle, okay? North, like on a compass, north is considered like 0 degrees. Okay, and every time as you go clockwise around the circle, the degree count goes up based on how many degrees you've gone around the circle. Okay, so going from what reading would east be then? So if I go 90, if I go 1/4 of the way around the circle, 90 degrees, yeah. What would halfway around the circle be? 180, yeah. And then what would 3/4 of the way around be? 270, yeah? Yeah. All right. So do we feel comfortable about north, east, south, and west? Okay. Northeast is halfway between north and east, i.e. it's halfway between 0 and 90. What number is that? 45. That's why it's 45 degrees. Does that help? Now the next one, north, northeast, let's look where that is. It's halfway between north and northeast. So what's halfway between these two numbers? 22.5, yep. Okay? Then we're supposed to get west-southwest. What do you think, what should we find first that'll make that question easier to answer? Southwest. What's southwest? Halfway between 180 and 270. Where's that? 225, right?
270. Could you just go to 270 and subtract 22.5?
Yeah, you could do that too. And then what's halfway between 225 and 270? $247.5. All right, we feel okay? A little bit better? No archery circles. We'll probably see more of those. Yeah, but yeah. I did a little bit of orienteering back in my day. Find a bearing. Make sure your palm is flat. All right, sketch a part E. Can I move on to part E? Sketch a diagram of a ship on this course. So the coordinate axes are a lot like a compass, except 0 degrees is on the right now. Okay? So this would be 90 degrees. This would be 180. This would be 270. And this is technically also 360. Okay, so right, so this is just to reiterate that we measure an angle, like in trigonometry, we're doing trigonometry this unit. In trigonometry, we measure an angle up from the positive x-axis, okay? So if a ship is moving at a 35-degree angle, right? Let me ask you this first. What direction would the ship be going in if it were going at a 45-degree angle? Like halfway, right? Halfway between 0 and 90, right? So 35 is just a little bit less than that. 10 degrees less. So it'd be going this way. What's that? Yeah, I'm just going to draw I'm just going to draw a 35-degree angle. I just need a sketch. Yeah, just a sketch. I don't need like the exact angle. This is working on figuring out like what quadrant each different angles are in. So B, for a 128-degree angle. So let's label our axes. This is 0 degrees, 90 degrees, 180 degrees, 270 degrees. A 128-degree angle. Okay? What quadrant would that be in? Top left, right? Okay? What's halfway between 90 and 180? 135. So a 135-degree angle would be right exactly halfway between those two, right in the middle of that second quadrant. But we want a 128-degree angle. So that would be a little more pointed toward the 90-degree axis. Okay? So be 128 degrees. Like that. So this is a 128-degree angle. Okay. Can you guys draw C on your own maybe? So 0 degrees, 90 degrees, 180 degrees. Try drawing C on your own. What's that?
Why would you 0 at the top? Like,
that's because that's the way like mathematicians defined it in the 16th century. Yeah, that's like the true answer. Yeah. Don't quote me on the century, but that's how mathematicians defined it. I told you guys this was the hardest quarter of high school math. So which quadrant would a 310 degree angle be in? The bottom right, right? So halfway between 270, this is also 360. 270 and 360 is, what's that, 305 or 315? So halfway would be 315. So 310 would be a little less than halfway. So we need to point a little closer to the 270 axis, the 270. Okay. Okay. So this angle right here, that's a 310 degree angle. Okay. So this exercise, I'm really trying to like hammer home like which quadrant each angle's in. Okay. Yeah.
So is there like a title for each quadrant? 'Cause I think there is.
Yeah, this is called quadrant 1, 2, 3, and 4. That's a good question. Yeah. And 0 degrees this time is on the positive x-axis. That's not a terrible idea to just label the angles every time you do a problem like this. Okay. F, navigation. The captain of the tourist boat, Julia. We don't have a Julia in here, do we? I don't think we do. No. Sorry if I forgot. Sorry if you're in here, Julia. I forgot about you. Captain of the tourist boat, Julia, out of Oak Harbor, follows a 38-degree course for 2 miles and then changes to a 47-degree course for the next 4 miles. Draw a sketch of this trip. So here's our axes right here. Okay, here's 0 degree. Here's 0 degrees. Here's 90 degrees. 270 degrees. Oh, wait, sorry, 180. All right, let's do the first part. Okay, 38-degree course. Okay, where would 38 degrees be? Be in the top right. It would be so halfway is about 45. Halfway between 0 and 90 is about 45. So it would be a little more than halfway or a little less than halfway? A little less, okay? So that's just a rough sketch. Okay, we don't need to get the compass out. Compass and protractor out. Okay. So he's going to follow a 38-degree heading for 2 miles. This is 38 degrees. Follows it for 2 miles. Okay. And then a 47-degree course for the next 40 miles. Here's how I want to do this. Let's start from the origin and draw a 47-degree course. Where would that be? So 45 is about halfway, so 47 is what? Just barely above halfway. Barely above halfway. And he's going to do that for twice as long, or she. Be female captain too. All right. Okay, so just a little, so twice as long and a little more than 45 degrees. Okay. All right, so let me draw that in a different color. So twice as long for a little more than 45 degrees. And then what I'm going to do is I'm just going to copy it. And then move it to where, oh shoot. Move it to the end of that first stretch of the journey. Okay. So we did 2 miles for a 38-degree course for 2 miles. And then we switched to a 47-degree heading. Traveled 4 miles. Did I say 4? 2. 2 miles at 38 degrees, switched, we took a left turn, and we went 4 miles. You guys see that? Okay. Anyone like a pilot in here? Anyone have their pilot license? We do that a lot in flying. Yeah. No protractor. Thank goodness. Are you a sailor? You sail? Anyone sail? You sailed to Italy. Oh, you guys are sailors? You sail? You sail? Anyone seen Moana?
I'm a big Moana guy. That's very, it's such a beautiful. Dude, we should go sing.
Well, you seen Moana when she's like teaching you how to navigate? That'd be a funny like touchdown celebration. Danny O'Neill, like, make sure. Alright, G.
On the starboard bow, on the starboard and the starboard and port side is double. So it's like on the left. Yep. So you take starboard side to the bear right. And then see if he's
Alright guys, let's focus on G real quick.
It's so scary.
Let's get G knocked out. Yeah, I think so. I got yours. I'm going to print yours out. So here's what's going on, guys. So I'm going to draw. I don't like this sketch from the book. There's 2 boats. All right. It doesn't matter that they're Coast Guard. All right. We got 2 boats. One is traveling. Let's do a green dashed line. They travel the same distance from the origin. They start at the origin right here, okay? One's going to travel with a bearing of 42 degrees in 30 minutes. So about like here. 42 degrees, 30 minutes. I don't know about you, but I do not like working with the DMS angles. Are you guys okay if I convert to decimal real quick? Okay, so 42 plus 30 over 60. One's going to go at 42.5 degrees. Okay. The other one, let's do, I'll call it the blue ship, is going to travel with a heading of 52 degrees and 12 minutes. Okay, so about somewhere around here. Okay, 52 degrees and 12 minutes is 52.2 degrees. And what they want, so here's where the blue ship is, here's where the green ship is. They want to know approximately how far apart they'll be. And I think, anyone have any idea? Anyone realize what's going on here, what formula we're going to use? Arc length, yep, exactly, yep. So there's some angle, right? So we want this. The distance between them is approximately the same as the arc length between them, s. Okay. How do we find that? What's the arc length formula? S equals r theta. Yep. What's my r? What's my r here? 25. Yep. How far they are from the origin. What's my theta going to be? How do I come up with theta? Let's come up with theta in degrees first and then convert it to radians. What's theta going to be? Yeah, we're going to do it in degrees first and then convert it. Because I want to explain where the angle came from. Yeah, so the angle, right, this is like the angle of the sector, right? It's the angle between the blue and green lines. It's the difference between 52.2 and 42.5, which is what, 6.7? Okay. 6.3? It's all good. I don't know either. So 9.7. The angle between them is 9.7 degrees. What is that in radians? Yep, exactly. So 0.17. radians. So then the distance is going to be 25 times 0.17 radians. So I got, and this is on statute miles, 4.2 miles. So let's do 4.1 homework for next time, okay? Can you just come back here and get it? Nice. What's living here?
That road looks a little, that's great work, Dave. We're switching it back to what it was.
What do you mean?
I think we had 500. No, what up, Greg? Right there. I only see the my left leg.
What is that? Hey, did anyone get their white calculator in here? Break?
Oh, yeah, over break, that's me.
Is it you? Okay.
I was just about to ask you. I need to
We get to do complex numbers today.
How are you? Is it like more from that same homework spot?
Yeah, it's the same thing. Yeah, that's what you need. Yeah. I have an iPad. I have an like the full
Religion. It's not religion, world language.
That's not world language.
It's in the red. It's in the red.
No, it's either 2 or 3.
Oh, wait, no, it's one. You're in the red.
Yeah.
Oh, yeah. I think you're in the red.
I'm standing at the edge of the
Whatever heading is always 1. World language is
Oh shoot! I forgot to turn this off.
religion is 2.